Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over problems 21 to 24 of the Geometry Common Core Regents exam for June 2016. All right, let's take a look at question 21. It says in the diagram of triangle ABC, points D and E are on segment AB and CD, respectively, such that segment AC is parallel to segment DE. If AD is equal to 24, DB is 12, and DE is 4, what is the length of segment AC? So one thing you want to remember concerning the AA similarity postulate is that if you have two angles in a triangle that are congruent to two angles in another triangle, then the two triangles are similar, okay? And if two triangles are similar, then corresponding sides are in proportion. Now we have a situation where segment AC is parallel to segment DE. Now what happens if we extend these segments? Just basically make them into lines. So if this were a line and this were another line, what we'll have is two parallel lines cut by a transversal. If you have two parallel lines cut by a transversal, this angle and this angle are considered corresponding angles. And what do we know about corresponding angles when you have two parallel lines cut by a transversal? Corresponding angles are congruent. Okay, so let's write down the statement. So since segment AC is parallel to segment DE, that implies that angle CAB is congruent to angle EDB. And that is because corresponding angles of parallel lines cut by a transversal are what? They are congruent. Okay, so this angle right here and this angle right here are corresponding angles and they are congruent. All right, so we have the A first set of angles that are congruent. So we need another set of angles in the two triangles that are congruent so we can conclude similarity, okay? But check this out. We know that angle B is common on both triangles, okay? So angle B is congruent to angle B. That's by the reflexive property of congruence, okay? So this angle is congruent to itself. So what can we conclude? We can conclude that triangle ABC is similar to triangle, so we have ABC, it's congruent to DBE, triangle DBE. And the reason is because of the AA similarity postulate. All right, okay. Now, since these two triangles are similar, then we know that corresponding sides are in proportion. Okay, so now we can now find AC. Now let's go ahead and put in the measures that we're provided with. Let's see, AD is 24, DB is 12, DE is 4, and AC is what we're looking for. Okay, so we're just gonna set up the following ratio. To find AC, we have AC over, AC over DE is equal to AD over DB. Okay, so AC over DE is equal to, so if we look at the longest side, the slant side of triangle ABC, we have AB over, and then for the smaller triangle, the corresponding side to the AB on the big triangle is DB. Okay, AB over DB. So this is what we mean by saying that corresponding sides are in proportion. Okay, so AC corresponds to DE, and then AB corresponds to DB. Okay, so we're looking for AC, so we're going to have AC over DE. The measure is provided for us. DE is 4 equals AB. AB is AD plus DB, right? 24 plus 12. 24 plus 12 divided by DB. DB is 12. All right, so we just solved this proportion for AC. Okay, so we have AC over 4 equals 24 plus 12 is 36 divided by 12. That yields AC over 4 is equal to 36 over 12 is 3. And then we'll simply multiply both sides by 4. And then we get AC is equal to 12. So our answer is option number 2. All right, let's take a look at problem number 22. It says triangle RST is graphed on a set of axes below. So we have the triangle. How many square units are in the area of triangle RST? Okay, so we're basically trying to figure out the area of this triangle right here. So before we get started, let's go ahead and write down what the formula for the area of a triangle is. Formula is 1/2 for the area of a triangle is 1/2 base times height. So we need to know the base and the height. Okay, looks like RS is the base and ST the height, or you can call it ST the base and RS is the height, but we're not sure yet. How can we know for certainty that these two are the base and the height? In order to arrive at that conclusion, the base is always perpendicular to the altitude of the triangle. Okay, so the question is RS and ST, are they perpendicular to one another? To verify that, we need to look at their slopes. So what is the slope of segment RS? Slope of segment RS, we're going to do rise over run. So let's see. Let's make it red. So we're going to rise and run. Okay, so you're going to do 1, 2, 3, 4, 5, 6. You rise 6, you run 1, 2, 3. So the slope of RS is simply 6 over 3, which is equal to 2. Okay, now what is the slope of ST? Segment ST. So to do that, we're going to do rise over run, but in this case, let's see what we're going to do here. We're going to fall. Let's use blue so it's different. We're going to fall. That's a negative rise, and then run. Okay, so let's see how many units we have here. Let me just move the segment a little bit. See how many units we have here. So we're going to count our rise, which is going to be 1, 2, 3, 4, 5, 6. Negative 6 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Over 12, so this negative reduces to negative 1/2 if you divide top and bottom by 6. Okay, now since the slope of segment RS is the negative reciprocal of the slope of ST, what does that automatically imply? It means that those two segments are perpendicular. RS is perpendicular to ST. Okay, so that means that if you want to call if RS is the base, guess what? Then segment ST is going to be the height, okay, or the altitude of the triangle. All right, so all we just need to do now is just find the base and the height. So this would be our base right here. This segment right here is going to be our base. and then this length right here will be our height. All right, so let's go ahead and figure them out. Now, in order to do it, we are going to make use of the Pythagorean theorem, or you could use coordinate geometry. Okay, if you use a coordinate geometry, all you do is you figure out the coordinates of point R and point S, and then you use a distance formula to compute the length. Okay, but I'm going to use a different route here. We want to find RS. This is a right triangle. See, this is 90 degrees right here. This is the hypotenuse, so we're going to call it C. In this triangle right here, RS is basically going to be C. So let's apply the Pythagorean theorem. A squared plus B squared equals what? C squared, right? So let's call this A and call this B. So the reason why I'm using the Pythagorean theorem is we can just count boxes and simplify the whole process. So A is 3 units long, so 3 square plus B. B is 1, 2, 3, 4, 5, 6. 6 units long equals C squared. Okay, now let's solve for C, which is RS. So 3 squared is 9 plus 6 squared, which is 36 equals, let's change this to RS square. 9 plus 36 is 45. 45 is equal to RS square. So next we're going to take the square root of both sides of the equation. So RS is root 45. So let's go ahead and break this down. So we can take out 5, you're left with 9, and then you break down 9 into 3 times 3. So these two are identical factors, so we can take the square root of both of them, and this comes out as a 3. Okay, so root 45 is equal to 3 rad 5. And that's basically what the length of our base RS is. So RS is equal to 3 root 5. Next, we need to find the height of the triangle, namely segment ST. Okay, so let's go ahead and compute that. Same process. So we want to now find ST. Now, if you look at the triangle here, ST is the hypotenuse of this right triangle right here. So ST is also a C. Okay, and then this is my A, and then this is my, well, we can call this B. All right, so A is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We already counted it over here. So A is 12, and B is 6, right? 1, 2, 3, 4, 5, 6. So B is 6, so we're looking for C. So to do that, we're going to be using the Pythagorean theorem again. A squared plus B squared equals C squared. So A is 12, 12 squared plus B squared, 6 squared equals C squared. C is ST, that's what we're looking for, so ST squared. 12 squared is 144 plus 6 squared, which is 36, equals ST squared. So we're going to take the square root. Well, let's add first. So if we add these two, we end up with 180 equals ST squared. And now we're going to proceed to take the square root of both sides of the equation. And that gives us ST. The height of the triangle equals to root 180. So we need to simplify this. So let's extract prime factors, okay? So I take out 2. 2 goes into 180 90 times. Take out another 2. 2 goes into 90 45. We can take out a 5, left with 9, and then 3, and then 3. So whichever factor repeats can come out as 1. So 2 times 2, the square root of 2 times 2 is 4. So that comes out, the square root of 2 times 2 is 2, sorry. So this 2 come out as 2. And then the square root of 3 times 3, that comes out as 3. So the simplified form of root 180 is 2 times 3 And then this 5 is by itself, so it remains as a radicand. 2 times 3 is 6, so we have 6 root 5 as the height of our right triangle. Okay, so let's go ahead and write down those pieces of information. So we have the base is b is equal to 3 root 5, and the height h is 6 root 5. All right, so our area is 1/2 base times height, as indicated earlier. So we have 1/2, the base is 3 root 5 times 6 root 5. All right, so let's multiply this out. We're going to have 3 times 6 is 18. 18 times root 25 divided by 2. Okay, so what is root 25? That's 5, right? So 18 times 5 divided by 2. 2 goes into itself once and goes into 18 9 times. 9 times 5 yields 45. Okay, so that's the area of our triangle. Answer to number 22 is option number 3. All right, let's take a look at number 23. It reads, the graph below shows segment AB, which is a chord of circle O. The coordinates of the endpoints of segment AB are 3, 3, and 3, -7. The distance from the midpoint of AB to the center of circle O is 2 units. Question, what could be a correct equation for circle O? Okay, so this is a segment right here. And you're told that the distance from the midpoint to the center of circle O is 2 units. So let's find out where the midpoint of this segment is. This chord right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So midpoint will be 5 units down. 1, 2, 3, 4, 5. Okay, so there goes the midpoint. Okay, so we know that the distance from this center right here to from this midpoint to the center of the circle is 2 units, okay? So is it 2 units to the left or 2 units to the right? We don't really know. So let's go 2 units to the left. So this could be the center, or 2 units to the right. That could be the center. So we have 2 potential centers here. So this could be our center 1, let's call it O1, and this could be our center 2, O2. All right, so if this is the center of the circle, then this is a chord that touches a circle, then this right here, this segment from the center to that point will be the radius of the circle, okay? So we're gonna basically sketch a circle that has this length right here as its radius. So let me sketch it with the aid of this computer. So from there, you just draw your circle down. That's one possible solution, okay? Another solution could be from here, like that, all right? But you have a different center. So we're gonna do the first one first, and then see if we get the answer that we desire. If not, then we will do the second circle. Okay, now for circle 1, what do we need to write down the equation of a circle? We need the radius and the center. Okay, so we're going to be plugging it into the center radius form of the equation of a circle. So let's see what we can find here. We can easily determine the center is 1, -2. So the center is 1, -2. Just reading it from the graph using this first circle, circle 1. What else do we need? We need the radius. Okay, so we need to find the radius r. Now we have a right triangle here. So we can call this A, B, and our radius is going to be C. So how do we find C? We use the Pythagorean theorem. Okay, we know that A squared plus B squared equals C squared. A is 2 units long, plus B is 1, 2, 3, 4, 5, 5 units long, so 5 squared equals C squared. 2 times 2 is 4, plus 5 times 5, which is 25, is C squared. Add these two, C squared is 29, and then you just take the square root of both sides, and that gives you what C is. Now, what is C in the context of this problem? C is the radius, okay? So the radius, which is root 29. So we have the center and the radius. We can use the center radius form of the equation of a circle to write down what the equation of the circle is, okay? So the formula is as follows. You have to remember this, which is basically that x minus h squared plus y minus k squared equals r squared, okay? Where the center is basically hk and the radius is r. All right, so the center is 1, negative 2. So when we're plugging it into the equation of a circle, so h is going to be, let's see, hk 1. Okay, k is negative 2, and r is root 29. So we'll plug all this into this equation. We are going to have x minus 1 squared plus y minus 2 minus negative 2 squared equals root 29. Don't forget to square the radius, okay? Root 29 squared. So we simplify that. We have x minus 1 squared plus y plus 2 squared equals 29. And the answer is option number 1. Option number 1 is your answer. All right, let's take a look at 24. It says, what is the area of a sector of a circle with a radius of 8 inches and formed by a central angle that measures 60 degrees? Now, to get started, let's write down what the formula for the area of a sector is, okay? So our formulas are as follows. This is for the area of a sector. So we have A equals theta over 360 times pi r squared, or A equals theta over 2 times radius squared. Now what's the difference? The formula on the left is for a situation where the angle is provided in degree format. And the second formula applies to a scenario when the angle is provided in radian format, pi radians, okay? So which one are we going to use for this problem? If you take a look at this problem, you notice that the options are in radian format. So that automatically tells us that we will be using the second variation of the area of a sector formula, okay? So since the uh, since the answers are in radian format, since the answers are in radian format, we use the second formula, okay? Okay, so if you notice though in the question, the angular measure is provided in degrees, so we have to change the theta into radians, okay? So theta convert so theta must be converted converted from degrees to radians. Okay, so that must be the condition in order to use this formula right here. So we have 60 degrees. What is 60 degrees in radian format? We simply multiply by pi over 180. Pi radians over 180 degrees. If you simplify this, the zeros cancel out, cancel. 6 goes here 1, 6 goes here 3 times. So 60 degrees is basically pi over 3 radians. And that's what theta is going to be. Okay, so we're good to go. Now our area, theta over 2 times r squared, as indicated in this formula right here. So let's just plug in theta and the radius into this formula to calculate the area of a sector. So we have theta is pi over 3 divided by 2 multiplied by the radius, which is 8 squared. Okay, so now we can write 2 as a fraction. And then if you're dividing 2 fractions, you multiply the top by the reciprocal of the bottom. And then 8 squared is 64. All right, so let's see, what do we have here? We have 64 times 1 times pi, 64 pi divided by 6. You reduce by dividing the top and bottom by 2. Divide by 2, divide by 2. And you have your area as 32 pi over 3 square units. Answer for number 24 is option number 3. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Geometry Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe for the remainder of this review series. If you have any questions, just place it in the comment section below, and we'll be more than glad to support you. More clips can be found on Mathgotserved.com. Thanks again for watching, and have a wonderful day.